A colossal statue sits half-carved from a cliff face, frozen forever at the moment the work stopped. That silent pause is a question waiting for an answer. This is a journey into the architectural methods behind unfinished ancient projects. We are going to reconstruct the blueprints of ambition itself, to understand how and why the greatest plans of the past were left incomplete. By the end, you will gain the tools to see any ancient ruin not as a broken thing, but as an open book on engineering and human nature. We will uncover what a cracked obelisk can teach us about supply chains, and how a ghost city reveals the true cost of political power. What does an unfinished building tell us about the civilization that dreamed it? The line between a ruin and an unfinished project is as sharp as a mason's chisel. One is a story that reached its final chapter, then slowly faded with the centuries. The other is a sentence cut off mid-thought, a blueprint discovered on the drafting table, its final lines never drawn. This distinction is our first and most important tool. To reconstruct the methods, we must learn to read these frozen moments. An unfinished site is not a victim of collapse or conquest. It is a deliberate pause, a snapshot of the construction process itself, preserved in startling clarity. Here, the architect's intent is not hidden under layers of renovation or decay. It is visible in the fresh tool marks on a stone block, in the orderly stockpile of materials left for a tomorrow that never came, in the temporary ramps and scaffolds that were never dismantled. It is a time capsule sealed not by a lid, but by a sudden, silent stop. A perfect example waits in the granite quarries of Aswan, Egypt. Here lies the unfinished obelisk, a single piece of stone meant to stretch 137 feet toward the sun. It still rests in its bedrock cradle, attached on all sides. This isn't a broken monument. This is a monument in its embryonic state. The obelisk's surfaces are a textbook of ancient quarrying. You can see the precise channels cut by workers using simple stone pounders, a technique of relentless, patient percussion. You can even see where a flaw in the granite caused a catastrophic crack, forcing the entire project to be abandoned right then and there. That moment of failure, that single flaw, gives us more insight than a dozen finished obelisks ever could. It shows us the limits of their technology, the risks of their ambition, and the exact point where their method met an immovable problem. This is the power of the unfinished. It removes the guesswork. When we study a completed pyramid, we theorize about how it might have been built. But when we study an abandoned quarry or a half-built foundation, we are witnessing the how in progress. We see the logistical choreography where materials were staged, how workers moved, what step came next. It allows archaeologists to reverse engineer the entire process without the confusing noise of later damage, looting, or repurposing. By learning to spot these frozen moments, we set the stage for a true reconstruction. We are no longer looking at a mystery. We are looking at a paused film reel, waiting for us to press play and watch the ancient builders at their work. The unfinished obelisk gives us the how, but it leaves a deeper question unanswered. What was it for? This is the primary challenge in our reconstruction, a puzzle with no instruction manual. Ancient builders rarely left behind detailed blueprints as we know them. Their plans were held in memory, sketched in ephemeral materials, or encoded in the geometry of the site itself. To understand their intent, we must become detectives, learning to read a language written in stone and soil. We start with the silent testimony of proportions. The foundational layout of a structure speaks volumes about its ultimate scale and purpose. A wide, circular foundation trench hints at a rotunda. A long, rectangular base with regularly spaced post holes suggests a grand hall. By measuring these footprints and analyzing their geometric relationships, we can extrapolate the volume and form of the building that was meant to rise above. A powerful example lies at Göbekli Tepe in Turkey, one of the world's oldest known temple complexes. Here, researchers found something extraordinary. The oldest structures were smaller, circular enclosures, but over time, the builders deliberately buried these entire monuments, sealing them with earth and rubble, only to construct newer, larger, and more elaborate circles directly on top. This isn't random construction. It is a clear, sequential architectural vision. The intent evolved with each new generation building upon, and literally over, the sacred geometry of the last. We see a civilization's growing ambition fossilized in layers of soil. Another key method is comparative analysis. When we find the foundation of an abandoned Roman temple in Gaul, we don't have to guess in a vacuum. We can compare its dimensions, its column spacing, and its orientation to a fully completed temple from the same era and region, perhaps in Italy itself. The similarities become a template, allowing us to mentally reconstruct the roof line, the height of the pediment, the placement of the altar. It's like finding a single piece of a known jigsaw puzzle and knowing exactly which picture it belongs to. Finally, we interpret the smallest of clues. The direction of tool strokes on a half-dressed column can tell us which way the mason was moving, revealing his technique. A sudden change in the type of mortar, or a switch from limestone to granite in a foundation course, can signal a shift in design or a problem with supply. Even the arrangement of stone blocks in a stockpile, sorted by size and shape, outlines the next phase of construction that never began. Each of these fragments is a word in a lost sentence. By patiently assembling them, we start to hear the architect's voice, to see the ghost of the building that was meant to be. We are not just looking at ruins. We are reading an interrupted dream. The ghost of a building lives in the dirt beneath it. Every construction project, from a simple hut to a soaring temple, creates a physical diary written in layers of soil, stone chips, and abandoned tools. To read that diary, we turn to our first powerful method of reconstruction, stratigraphic archaeology. Think of it as the science of sequence. Just as a tree's rings record years of growth, the ground at an unfinished site holds a pristine, chronological record of the builder's work. Each action, from digging the foundation trench to laying the final floor, leaves a distinct layer or stratum. By excavating with the care of a surgeon, archaeologists can peel back these layers in reverse order, literally rewinding the construction tape to see how the project unfolded, step by step. This process answers fundamental questions about ancient methods. Did they build the walls first and then fill the interior? Or was it the other way around? Were ornate column capitals carved right there on the ground, or were they finished elsewhere and then lifted into place? The layers hold the evidence. A vivid example of this principle in action is the Roman colonial city of Timgad in modern-day Algeria. Founded as a perfect military grid, its original stone plan is remarkably preserved. Through stratigraphy, researchers have traced the city's intended growth beyond that initial grid. They can see where new streets were surveyed, where foundations for expanded forums and temples were laid, and then, tellingly, where the work simply stopped. The layers show a clear, ambitious sequence of expansion that was frozen in time, likely halted by shifting political priorities or economic strain. This method does more than show us the steps. It reveals the rhythm and the stumbling blocks. A sudden, thick layer of rubble might indicate a period of rapid demolition to clear space. A long period with no new layers might signal a harsh winter, a shortage of funds, or a labor dispute. By building this physical timeline, stratigraphy lets us identify the potential bottlenecks, the moments of delay that may have snowballed into the final, permanent halt. It transforms a silent, empty site into a dynamic workshop, allowing us to hear the echoes of the last day of work and understand why the tools were laid down for good. But the story is not just in the layers of dirt, it is in the shape of the land itself. Our second method of reconstruction steps back, far back, to see the grand design hidden by time and vegetation. This is the power of geospatial analysis, where modern technology grants us a god's eye view of ancient ambition. Tools like LiDAR, which stands for light detection and ranging, can peer through dense jungle canopies to map the ground beneath with astonishing precision. From an airplane or a drone, it fires millions of laser pulses, building a three-dimensional map of the Earth's surface. This technology has revolutionized our view of sites like the ancient Khmer city of Ko Ker in Cambodia. Here, LiDAR revealed a sprawling, unfinished network of moats and massive earthworks surrounding the central temples. We can now see the city's intended footprint, a grand plan of water and wall that was abruptly halted, likely due to a sudden shift of the capital back to Inca. The scan shows the ghost of a city that never was, its defensive lines sketched onto the landscape but never fully realized. On a smaller, more intimate scale, we have ground-penetrating radar. This device sends radio waves into the earth, which bounce back when they hit something solid, like a buried wall or a cache of stone blocks. It allows archaeologists to see beneath the soil without ever lifting a shovel, preserving the site while revealing its secrets. Imagine discovering the foundation of a planned wing of a Roman villa, complete with outlines of rooms and corridors, all hidden just inches below a farmer's field. These tools collectively build something extraordinary, a hyper-accurate three-dimensional digital model of the unfinished site. This virtual model becomes a sandbox for reconstruction. We can digitally complete the walls, test the structural integrity of different roof designs, and even simulate how sunlight would have fallen through non-existent windows at the summer solstice. This digital playground lets us test hypotheses in ways that were once impossible. Take the Nubian pyramids at Marwa in Sudan. They are notably steeper and narrower than the iconic pyramids of Giza. Some at the site appear unfinished with rough, sloping sides. For a long time, scholars debated whether this was simply a stylistic choice or a different construction method halted mid-process. Using three-dimensional models created from laser scans, researchers could digitally manipulate these forms. They could test if the steep slope was the intended final angle, or if it represented an earlier construction phase that would have been smoothed and clad in stone. The virtual reconstruction suggests these pyramids may indeed represent a distinct, local architectural template, a conscious cultural statement rather than a failed imitation. It allows us to separate unfinished work from finished design, to see the cultural fingerprint in the geometry. With this bird's eye view and digital clay in our hands, we move from observing the pieces to actively testing how they were meant to fit together. Yet, even the most perfect model lacks one crucial ingredient: the human hands that shape the stone. To find them, we must look closer at the marks they left behind. Every tool leaves a signature, and every material carries a map. Our third method of reconstruction moves from the grand scale of the landscape to the microscopic world within the stone itself. This is the forensic science of ancient construction, where we learn to read the stories locked in the grain of marble, the chemistry of mortar, and the unique scars left by chisels. A block of granite is not just a block, it is a geological fingerprint. By analyzing its mineral composition and comparing it to known quarries, we can trace its journey across continents. Imagine discovering that the half-carved columns for a temple in ancient Ephesus were made of marble from a quarry on a distant island. This single fact reconstructs an entire hidden world, a supply chain of ships, barges, and laborers, all dedicated to feeding the ambition of a single building site. The sudden absence of that distinctive marble in the later, unfinished layers tells an even more powerful story. It speaks of a trade route disrupted, a quarry exhausted, or a political alliance shattered. The material itself becomes a historical document, recording the moment when the lifeline to the building's heart was cut. equally telling are the marks left by the tools. The surface of an unfinished piece of stone is a frozen moment of craftsmanship. In classical Greece, masons used a specific pointed chisel for the initial rough shaping of marble. The distinct stippled pattern it leaves is unmistakable. If we find a column drum covered only in these point marks, we know the work stopped at the primary roughing out stage. If we see the smoother grooves of a flat chisel, the stone was moving toward its final form. This allows us to sequence the construction process with remarkable precision. We can identify which parts of a building were considered priority and which were left for later. It reveals the assembly line of antiquity, showing us the order of operations that the master builder intended to follow right up until the day the work ceased. Then there is the humble mortar, the glue that holds civilizations together. By taking a coarse sample from between two unfinished bricks, scientists can perform a kind of archaeological autopsy. They can determine the exact mix of sand, lime, and water. More crucially, they can often tell if the mortar had begun to set. If the chemical bonds show only partial crystallization, it indicates work stopped suddenly, perhaps within a single season. The mortar never got the chance to fully harden, preserving a snapshot of the very weather and conditions of that final workday. This subtle evidence helps us distinguish between a project abandoned in a planned, orderly halt and one stopped by a sudden, catastrophic event. It answers whether the workers left at the end of the day expecting to return or if they fled. Together, these material clues let us reconstruct not just the building, but the vast, fragile network that sustained it. We map the arteries of commerce that brought stone from the mountains and timber from the forests. We see the points of vulnerability where a drought could halt the production of lime, or a war could embargo a vital metal for clamps and reinforcements. A construction site becomes a microcosm of the entire civilization's economy and environment. Its silence, then, is not empty. It is the echo of a complex system breaking down. By listening to the stones, we begin to understand the immense logistical symphony required to turn a dream into stone, and what happens when the music suddenly stops. Yet for all this science, a haunting question remains. What was the human cost of that silence? The stones and the soil tell a story, but to feel its true weight, you must sometimes pick up the tools yourself. This leads us to our fourth powerful method, experimental archaeology, where theory meets the hard reality of sweat, muscle, and material. It is the ultimate act of reconstruction, not on paper or screen, but in the physical world. The principle is beautifully simple. If we want to understand why a task was abandoned, we must try to complete it using only the technology and materials available at the time. By doing so, we stop being distant observers and become temporary participants in that ancient workflow, encountering the very same obstacles the original builders faced. This hands-on approach generates data no scan or soil sample ever could. It answers the most human questions of all. How many people did this actually take? How long would it really have lasted? And what was the breaking point, not of the stone, but of the society trying to move it? Consider the monumental task of quarrying and moving the stone blocks for the Roman complex at Baalbek in Lebanon. Here, 3 colossal blocks known as the Trilithon, each weighing over 800 tons, sit perfectly fitted in a foundation wall. The quarry, however, holds an even more astonishing block, estimated at nearly 1,200 tons, left partially carved and attached to the bedrock. For centuries, scholars theorized about the methods used. Experimental projects have taken those theories into the field. Teams have reconstructed ancient Roman-style copper saws, using them with abrasive sand and water to cut through limestone. The process is not a swift slice, but a grueling, days-long grind of back-and-forth motion, consuming vast amounts of the abrasive material. This simple experiment provides a visceral understanding of the resource intensity. the sheer volume of sand and copper that had to be mined, transported, and managed just for the cutting phase alone. You feel the immense friction in your arms, and you suddenly comprehend the logistical mountain behind every smooth surface. Similarly, to understand the unfinished obelisks of Egypt, researchers have tried quarrying granite using nothing but dolerite stone pounders. This is not carving, it is a brutal process of repetitive percussion, reducing solid granite to dust and small chips through pure, relentless force. A team working for hours might only advance an inch or two. This tangible experience transforms abstract descriptions of labor into a profound respect for the endurance and coordination required. It allows us to calculate with new accuracy the number of worker shifts needed for a single obelisk, and to see how a single flaw in the stone could represent the loss of thousands of hours of collective effort, making abandonment not a failure of will, but a rational economic decision. Through these physical trials, we begin to map the invisible boundaries of ancient ambition. We learn where the limits of physics, physiology, and organization truly lay. A project might have been halted not by a lack of vision, but by a simple, crushing calculation. The number of workers needed to haul a single roof beam might have exceeded the available population. The food required to sustain them might have outstripped the region's harvest. The time investment might have simply outstripped the lifespan of the ruler who commissioned it. Experimental archaeology turns these societal pressures into something we can measure in blisters, in tons of sand, and in the aching pace of a stone saw. It shows us that the moment of abandonment was often a moment of stark clarity, when the dream finally met the immutable laws of the physical world and the fragile systems of the human one. Sometimes the stones themselves speak. Our fifth method of reconstruction turns to the most direct source of all, the written word. In rare and illuminating cases, the ancient builders left behind records of their ambitions, not just in stone, but in ink and clay. This is the world of epigraphic and textual analysis, where we cross-reference the physical skeleton of an unfinished site with the paper trail, or rather, the clay tablet trail of its creation. These texts are our closest link to the minds behind the monuments. In Mesopotamia, thousands of cuneiform tablets survive, acting as the administrative files of antiquity. They meticulously detail the construction of ziggurats, those massive step temples. One tablet might list the exact number of laborers assigned to a brickmaking crew for a single month. Another might be a receipt for a shipment of cedar wood from distant mountains, or an inventory of the bitumen, a natural tar, used to waterproof the structure. These are not poetic descriptions of glory, they are budget reports and work schedules. When we find an unfinished ziggurat foundation, these tablets allow us to reconstruct the staggering logistical machine that was supposed to operate there. We can see the plan in motion, and by noting when similar records stop appearing, we can often pinpoint the moment the bureaucratic support for the project dried up, sometimes years before the last worker left the site. A more subtle and powerful example comes from Egypt at the site of Tel el Amarna. This was the revolutionary capital built by the pharaoh Akhenaten, dedicated to the worship of a single sun disk, the Aten. The city was constructed at a breakneck pace. Its boundary stelae, the large carved inscriptions that mark the city's limits, tell a fascinating story. The earliest inscriptions are grand and confident, declaring Akhenaten's divine mandate and his vision for a perfect city for his god. But later stelae, carved as the city was still being built, show a noticeable shift. The language becomes less assured, the scale of the claims more restrained. Some inscriptions were even hastily recarved, as if the official story was being rewritten in real time. This textual evolution provides the crucial context that the archaeology alone cannot. The changing words mirror the growing political and religious isolation of Akhenaten's regime. They hint at dwindling resources, rising dissent, and a loss of faith in the project itself, both literally and figuratively. By the time of Akhenaten's passing, the textual record falls silent on new construction, and the city was abandoned almost immediately, its grand avenues left empty, its palaces half-decorated. The words on the stone tell us why the hand stopped working. Deciphering these texts allows us to overlay the human narrative onto the physical evidence. We move from counting bricks to understanding the king's anxiety. We shift from analyzing mortar mixes to sensing the treasurer's worry over a depleted granary. A sudden order conscripting farmers into a labor gang, recorded on a fragile piece of papyrus, explains the unfinished field wall we find at a remote outpost. The written record injects the element of urgent decision, of changing priorities and finite lifespans. It shows us that a project was often not abandoned because the builders could not finish it, but because the person who ordered it no longer saw the point or no longer held the power to command its completion. The dream did not fade, it was deliberately rescinded. With this fifth method, we complete the circle, marrying the hard data of the site with the fragile voices of those who conceived it. We have now assembled a full toolkit, from the stratigraphy under our feet to the words carved beside us. But to truly grasp the scale of what was lost, we must step back and witness the haunting grandeur of the most iconic unfinished project of them all. The granite quarries of Aswan hold a lesson in stone, 137 feet long. Here rests the unfinished obelisk, not a broken monument, but a monument in its making. It is the clearest window we have into the mind of an Egyptian master builder, a three-dimensional blueprint where every tool stroke is a word in a forgotten manual. The obelisk remains partially attached to the living bedrock, a single, titanic piece of rose granite that was meant to stand before a temple, catching the first and last light of the sun. Its surfaces are a pristine archaeological site, untouched by final polishing or the erosion of millennia standing upright. You can walk around it and see, step by step, how such an impossible thing was meant to be born. The process begins with the outline. Workers would have smoothed a section of the bedrock, then painted the precise shape of the obelisk onto the stone, a giant's sketch. Next came the trenches, using nothing but handheld balls of dolerite, a stone harder than granite. Teams of laborers would pound, day after day, creating a narrow channel around the sketched form. This was not cutting, it was a relentless, percussive act of reduction, grinding the granite into dust and small chips through pure, exhausting force. The trenches you see around the obelisk are these very channels, now empty, showing how the stone was isolated from the earth that bore it. Once the sides were freed, the incredible task of separating the bottom began. Workers would carve out small, arched chambers beneath the monolith, just enough space to insert wooden beams. These beams, soaked in water, would swell, creating tremendous upward pressure to crack the obelisk free from its cradle. Every stage of this marathon is frozen here, from the initial painter's line to the final leverage points. Then, the story takes its decisive turn. A deep, fatal crack snakes through the stone near the top. This flaw, hidden within the bedrock, revealed itself only after thousands of hours of work had already been invested. In that moment, the project transformed from a sacred duty to a practical calculation. The crack meant the obelisk would never stand, never bear the inscriptions of a pharaoh's glory. It was, in the most literal sense, a dead end. The workers laid down their dolerite pounders, the overseers closed their ledgers, and the site fell silent. This abandonment is not a mystery. It is a rational decision preserved in geology, showing us that even for a civilization of gods and kings, there was a point where the cost outweighed the divine command. Because of this perfect preservation, we can do more than just admire. We can calculate. Experimental archaeology, using replicas of those dolerite tools, gives us a rate of progress. The numbers that emerge are staggering. To create just the trenches around this single obelisk likely required a crew of several hundred workers, toiling in organized shifts for a period of 7 to 8 months. That is for the quarrying alone, before the even more perilous tasks of extraction, transport, and erection. The unfinished obelisk makes the invisible visible. It shows the immense human engine, the food, the water, the housing, the management, that hummed behind every polished monument we see today. It teaches us that every smooth surface in ancient Egypt rests upon a mountain of calculated effort and accepted risk. This single failed project, therefore, grants us a deeper appreciation for the ones that succeeded. It defines the fine line they walked, where a masterpiece on one side of the quarry faced the silent, cracked testimony of a near miss on the other. The silent quarries of Wales hold a different kind of ghost. Far from the sweeping Salisbury Plain, nestled in the Preseli Hills, lie the abandoned birthplaces of Stonehenge's most mysterious stones. Here, at sites like Carn Godog and Craig Rose Y Felin, the giant bluestone pillars were not cut but coaxed. The method was one of intimate geology. These are not free-standing boulders, but natural, vertical pillars formed by ancient cooling cracks in the rock face. Neolithic builders identified these perfect, ready-made columns. Their task was not to carve shape from chaos, but to separate a pre-formed gift from the earth. We can still see the evidence. At the quarry faces, there are gaping slots where pillars were successfully removed. Right beside them, however, are other pillars, partially worked and left in place. Wedge holes are visible where teams would have hammered in wooden wedges, then soaked them with water to exploit the swelling force, patiently prying the stone from its mother rock. Some of these wedging attempts failed, leaving the stone scarred but unmoved. This is a snapshot of a sophisticated extraction process, frozen at the moment of difficulty. It shows a deep understanding of material and fracture, but also its precarious limits. Each abandoned pillar represents a calculation, a decision that the effort to free this particular stone had surpassed its value. But the greater mystery begins once a stone was free. The journey from these Welsh hills to the Salisbury Plain spans 140 miles of Neolithic Britain. Reconstructing this route is an exercise in environmental empathy. We must strip away modern roads and fields and see the land as they did, a tapestry of dense forests, rolling ridges, and treacherous river valleys. The prevailing theory suggests a combined land and water route. The massive stones, each weighing up to 4 tons, would have been dragged on wooden sledges across miles of rugged terrain, then loaded onto rafts or barges for river segments before the final overland haul. This was not a single expedition, but a generational undertaking, a ritual of movement woven into the cultural fabric. So what caused the interruption the quarries suggest? The unfinished stones point to a slow unraveling, not a sudden catastrophe. One compelling possibility is climate. During the centuries of Stonehenge's construction, the climate in Britain was gradually becoming wetter. What were once firm paths could have transformed into impassable bogs. River levels may have risen, making water transport more dangerous or unpredictable. The very land they had mastered began to fight back, turning each logistical step into a quagmire. Alternatively, the hurdle may have been social. A project of this scale required a stable, coordinated society with surplus food and a unified purpose. Shifts in tribal alliances, conflicts over resources, or the rise of new spiritual ideas could have redirected labor and willpower. The priests or chiefs who championed the Bluestone journey may have lost their influence. The stones in the Welsh quarries, then, are more than unfinished objects. They are markers of a changed mind. Their abandonment likely forced a profound reimagining of the Stonehenge plan itself. Perhaps the builders realized they could not sustain the supply line from the sacred hills. The solution, they adapted. They turned to more local sarsen stones for the iconic outer circle and trilithons, while the bluestones they had already transported became a cherished, finite resource, rearranged within the monument over generations. The unfinished pillars in Wales are the key to this story. They tell us that Stonehenge was not a static, preordained design, but a living project that evolved in response to very real-world constraints. It is a testament not to rigid dogma, but to pragmatic resilience, showing how a sacred vision bent but did not break when the earth itself refused to cooperate. A pharaoh's radical dream rises from the desert sands only to vanish within a single generation. The city of Akhenaten, known today as Amarna, is not a ruin slowly worn down by centuries. It is a blueprint interrupted, a capital city built from nothing in a frantic 15-year sprint, then left to the wind when its creator passed. Here, the reconstruction of methods reveals something startling, not about failed engineering, but about the absolute power of a single individual and the brittle nature of a vision enforced from the throne. Akhenaten's mandate was urgent and total. To build a sacred capital for his one god, the Aten, he needed speed above all else. The archaeological record shows this pressure in every sun-dried brick. The construction method was one of ruthless standardization. Instead of quarrying and carving stone, which would take lifetimes, the builders turned to the earth beneath their feet. They used vast numbers of identical wooden molds to produce uniform mud bricks by the million. These bricks became the pixels of a new city, stamped out in an industrial rhythm that prioritized rapid enclosure over grandeur. The same principle of speed applied to the homes for the thousands of workers, priests, and officials who were ordered to move here. Archaeologists find row upon row of what they call the crowd house, a simple, repetitive floor plan built from those same uniform bricks. This was architecture as mass production, a city assembled from a kit to meet the deadline of a pharaoh's will. Walking through the remains today, you can see where this breakneck process left off. The city's major structures, its great temples and palaces, were largely completed in their mud brick cores. Their walls stood, their rooms were defined. But they were never meant to stay that way. The grand vision called for a final skin of beauty, a cladding of polished limestone and painted reliefs that would transform earthen boxes into luminous monuments to the sun disk. And this is where the reconstruction becomes particularly poignant. At many key buildings, you find prepared surfaces, smoothed and leveled, waiting for stone panels that never arrived. You find piles of gypsum plaster stockpiled for a decorative program that never began. The city was functionally built, but aesthetically it remained a skeleton. This unfinished state is a direct reflection of the project's fragile foundation, Akhenaten himself. The entire colossal effort, from the brick molds to the street grid, was an extension of his religious and political authority. There was no organic economic reason for the city to exist where it did, no deep-rooted tradition to sustain it. Its lifeblood was royal command, so when Akhenaten passed, the command ceased. The court, the priests, the workers, they simply had no reason to stay. The centralized system that built the city so quickly unraveled with equal speed. The stockpiled plaster hardened uselessly, the prepared wall surfaces gathered dust, the dream of a gleaming white city faded back to the color of the desert from which it sprang. Amarna teaches us that the most vulnerable point in an ancient project was often not a cracked foundation or a failed quarry. It was the mortality of its patron. It shows how architectural methods can be perfectly efficient for achieving scale and speed, yet utterly powerless against the turning of a political page. The city stands as a stark monument to a truth that stone can endure, but a vision built solely on one person's power is the most fragile material of all. High in the thin air of the Andes, a puzzle of red granite lies scattered across a mountainside. At Ollantaytambo, the stones themselves seem frozen in motion. Enormous monoliths, some weighing over 50 tons, rest on a steep processional ramp, as if the builders simply stepped away for a moment. Others are positioned near the Sun Temple's platform, their surfaces covered in precise, intricate cut marks, while a few appear abandoned along the ancient route from the quarry miles away. This is not a ruin in the traditional sense. It is a three-dimensional diagram of an Inca engineering process caught mid-stride. To reconstruct the method here is to witness one of history's most formidable logistical systems grappling with the sheer physics of the mountains they revered. The quarry for these stones lies across the Urubamba River Valley, high on a mountainside opposite the temple. The journey each block had to make is almost incomprehensible. First, they were eased down the quarry slope. Then they were moved across the rushing river, likely on a combination of earthen causeways and rafts. Finally, they faced the most daunting leg, a steep ascent up to the temple complex at Ollantaytambo itself. The Inca left us the tools to understand how this was possible, etched into the landscape. We can still see the remains of the massive ramps, built from field stones and packed earth, which provided a continuous, sloping roadway for the stones. They used no wheels, no pulleys, no draft animals. The power source was human. Teams of laborers, likely organized through the Inca meter labor tax system, would have moved the stones using ropes, wooden levers, and rollers. The process was a slow, rhythmic dance of leverage and coordination, inch by grueling inch up the mountainside. The scattered stones along this route are critical clues. They are not failures but waypoints. Each one represents a calculated pause, a place where the stone was stabilized before the next push, or where a lever point gave way. They map the path of least resistance up the mountain, a route chosen not for straight lines but for manageable gradients. The true genius, however, is revealed on the temple platform itself. Here we see the Inca construction method in its purest, unfinished form. The walls that were completed are legendary for their masonry, with colossal blocks fitted together so tightly a razor blade cannot slip between them. This perfection did not happen by chance. The unfinished blocks show us the meticulous, iterative process. Stonemasons would first rough shape a block at the quarry. Once hauled to the site, it was placed near its intended partner. Then, the painstaking work of dressing began. Using hammerstones of harder rock, they would peck at the surface of the new block, slowly refining its shape to match the contour of the stone already in place. They would test the fit, remove it, peck a little more, and test again. This cycle of trial and error, of constant refinement, is visible on the abandoned monoliths. Their surfaces are a landscape of small, deliberate impacts, a record of patient craftsmanship. This evidence challenges the simple narrative that the Spanish conquest alone halted the work. While the invasion certainly brought a catastrophic and final end, some archaeologists note that the distribution of stones and the state of the ramps suggest the project may have been struggling or paused even before Pizarro arrived. The sheer scale of the undertaking may have strained the local labor and resource pool, especially as the Inca Empire itself began to fracture from within during its own civil war. The unfinished temple, therefore, holds a double mystery. It showcases the breathtaking capability of Inca logistics and stoneworking, a system that could move mountains. Simultaneously, its frozen state whispers of a system under immense stress, a monumental ambition that may have been reaching its own natural limits even before history delivered its final, decisive blow. The stones at Ollantaytambo do not just sit there. They are caught in the act of becoming, forever showing us the immense distance between a quarried rock and a sacred wall, and the human will required to bridge that gap. Moving a 200-ton stone block is not an act of construction, but of choreography. The true genius of ancient architecture often lay not in the drafting room, but on the road. To reconstruct their methods, we must map the ghost roads, the vanished supply lines that fed the ambitions of kings. This is the realm of logistics, a silent, sprawling network that could make or break an empire's grandest dream. The colossal trilithon stones at Baalbek, each a leviathan heavier than a blue whale, did not simply appear at the temple site. Their journey from quarry to foundation is a puzzle solved by reading the landscape itself. Archaeologists scour the route for subtle depressions that might be the ancient equivalent of tire tracks, evidence of a road built for rollers or sledges. They analyze the local river's seasonal flow, determining if a flood season could have been harnessed to float the stones part of the way on barges. They even study the pollen trapped in soil layers along the suspected path, which can reveal if the area was once a cleared, managed roadway, stripped of trees to make way for these rolling mountains of stone. Every slope is measured, every possible friction point considered. This logistical map tells us the project was not just designed, it was engineered for movement, a testament to planning that considered the land as a partner in the process. But a road is nothing without the people to walk it. The question of who provided the muscle and why is central to understanding a project's lifespan. Labor systems varied dramatically. In many ancient kingdoms, a corvée system was used, where citizens owed a certain number of days of labor to the state each year, often during the agricultural off-season. This created a vast, rotating workforce, but one with a natural timer tied to the harvest. In other cases, like the Roman Empire, massive projects were often undertaken by the military, whose discipline and engineering skills were unparalleled. Skilled stonemasons, however, were usually highly valued professionals, paid and respected for their craft. The choice of system had direct consequences for a project's resilience. A project reliant on seasonal corvée labor was vulnerable to a single bad harvest. If the fields demanded every hand, the construction site would empty overnight. A project built by a permanent corps of soldiers or skilled workers was more stable but far more expensive to maintain. The point of failure in these human supply chains was often quiet and administrative. A ledger might show a sudden drop in grain shipments to a workers' village. A diplomatic record might note the collapse of a treaty with a neighboring region that supplied a critical metal for tools. These were the silent tremors that reached the construction site as a sudden shortage of hands, or a work crew sitting idle, waiting for a shipment of bronze chisels that would never arrive. This is how a royal vision turns to a skeleton. It is rarely a single, dramatic catastrophe. More often, it is a slow unraveling of threads in a vast, interconnected web. A blocked quarry upriver means no new granite. No new granite means masons are reassigned. Their absence delays the completion of a ramp. The delayed ramp means the seasonal workers, whose time is up, depart with a crucial hauling task half finished. One by one, the dependencies fail. The site manager, facing an impossible equation of missing parts and absent labor, makes the only rational decision. Work is suspended just for now until the supplies return, but just for now becomes forever. The workers disperse to other duties, the administrative attention shifts to a new crisis, and the frozen site is left as a monument to a broken system. The grand design remains, but its lifeblood, the constant flow of material and human energy, has been cut off. What we excavate centuries later is not a failure of imagination, but a map of logistical limits. We see the stockpile of perfectly cut stones that never found their wall, the empty barracks that once housed a legion of laborers, the road that leads impressively from the riverbank and then simply stops. In these absences, we read the true story of ancient ambition, a story written not only in what was built, but in the fragile, humming network that sustained the dream until the very moment it fell silent. The silent stones of an unfinished site hold more than history, they hold a structural riddle. These are not just abandoned plans, they are frozen engineering problems, waiting centuries for a solution. To reconstruct the method is to become a detective of physics, stepping into the worn sandals of the ancient master builder and facing the same daunting calculations of weight, balance, and force. Our most vital clues are the points of stress, the places where the design visibly strained against the limits of its materials. A crack propagating from the corner of a foundation, a subtle inward lean in a partially built wall, a change in the size or type of stone midway through a course. All these are silent alarms. They tell us where the builders encountered a problem they could not immediately solve, where the dream began to buckle under its own ambition. Take the enigmatic pyramid of Sekhemkhet at Saqqara. Unlike the clean, square bases of its famous neighbors, this unfinished structure reveals a rectangular footprint. This single, odd detail has sparked decades of debate among archaeologists and engineers. Was this the intended final shape, a radical departure from tradition, or was it merely an initial phase with the plan to expand it to a square as construction rose? By creating digital models and applying principles of structural analysis, modern researchers can test these hypotheses. They can simulate the weight distribution of a completed pyramid on that rectangular base, calculating the shear forces on the corners. Often, the models suggest that such a shape, at the immense scale of a pyramid, would have created critical points of weakness, especially in the lower courses. This leads to a compelling conclusion that the rectangular base might represent an error in the initial layout, a surveying mistake that became apparent only after significant resources were invested. The project's abandonment could then be seen not as a loss of will, but as a sober technical reassessment, an ancient project manager realizing the foundational math was flawed. These puzzles extend upward into the realm of daring voids and spans. Consider the skeleton of a Roman aqueduct, its great arches incomplete. The central keystone, that final locking piece, is missing. How did they plan to get it there? The temporary wooden support structure, the centering that held the entire arch in place during construction, was a feat of engineering in itself. If work stopped before the keystone was set, that centering would have remained in place, slowly rotting. Its eventual collapse would have taken the unfinished stonework with it. By studying the remaining voussoirs, the wedge-shaped stones of the arch, and their precise cutting angles, we can digitally reconstruct that wooden skeleton. We can understand its ingenious design, a temporary forest of timber that had to bear the entire dead weight of the stone until the moment the keystone clicked into place and the arch became self-supporting. Solving this puzzle makes us appreciate the breathtaking confidence of the Roman engineer, who designed not just a stone waterway, but a complex two-phase construction ballet where the failure of the temporary meant the destruction of the permanent. Engaging with these static mysteries does more than satisfy curiosity. It forces a profound empathy for the ancient mind. We must discard our modern knowledge of steel reinforcement and concrete. We must think only in terms of compressive strength, of gravity, of the simple lever and the inclined plane. We calculate loads using the mathematics they had, geometry and proportion. We consider the material strengths they knew from experience, the way a certain limestone bed could bear more weight than another, or how timber from a particular forest had the right flexibility for a support beam. In doing so, we move beyond seeing them as mystical builders. We recognize them as pragmatic problem solvers, confronting the same immutable laws of physics we do, but with a different toolkit. Their unfinished work is therefore the most honest textbook of all. It shows us their process of trial and sometimes their moment of hesitation when the scale of the challenge met the limit of their tested knowledge. In that silent pause between one stone and the next, we hear the most human question of all: how do we make this stand? A single, perfect dovetail joint in an Egyptian stone wall speaks of a hand that knew its craft intimately. To reconstruct the methods, we must finally meet the builders themselves, the hierarchy of minds and muscles that turned abstract geometry into lived reality. Behind every stone was a person, and behind every person was a role, a specialized place in an ancient and intricate machine. At the pinnacle stood the master builder, a figure often shrouded in legend. This was not merely an overseer, but a scholar of the visible and invisible worlds. He understood sacred geometry, the movements of stars for aligning temples, the hydraulic principles for aqueducts, and the compressive strengths of different stones. His vision was the project's soul. Then came the specialized artisans, the true artists of material. The stonemason who could dress a granite block so perfectly it locked with its neighbor without mortar. The bronze smith who forged the chisels that never broke. The carpenter who engineered the temporary wooden cranes and centering for arches. Their knowledge was not written in manuals, but in muscle memory and apprenticeship, passed from one generation to the next in a slow, careful tradition. Finally, there were the thousands of unskilled laborers, the engine of raw force. They hauled the ropes, moved the earth, and carried the water. Their contribution was defined not by specialized skill, but by endurance and coordination, often organized in shifts that turned human strength into a sustainable mechanical power. An unfinished site can reveal the sudden absence of one of these human components with startling clarity. Look at the decorative carvings on a half-finished temple frieze. In the earliest sections, you might see crisp, confident lines, intricate floral patterns where each petal is distinct. Then, as your eye moves along the wall, the work changes. The lines become shallower, less assured. The patterns grow simpler, as if the carver was unsure of the original design. This is more than a change in style. It is a signature of loss. It suggests the master sculptor, the one who held the full complexity of the design in his mind and hands, was no longer present. Perhaps he fell ill. Perhaps he was called away to another, more urgent project by a rival patron. His apprentices were left to continue the work, doing their best to imitate a technique they had not yet fully mastered. The stone itself records this rupture in the chain of knowledge. Similarly, a sudden shift from finely fitted ashlar masonry to rougher, smaller stones in a wall's upper courses can signal a crisis in logistics or skill. Maybe the skilled quarrying teams could no longer access the preferred stone bed. Maybe the masons who knew how to work that specific limestone were no longer available. The project had to adapt, downgrading its material and methods to keep going with who and what remained. This human dimension transforms a construction site from an engineering diagram into a living community. It was a place of noise, of shouted orders, of the smell of dust and wet mortar. It relied on a fragile ecosystem of trust and tradition. The master builder trusted that the mason understood the subtle curve of a column in tosses. The mason trusted that the laborers would steady the rope at the exact right moment. This entire ecosystem was vulnerable. A political purge could remove a visionary patron and his trusted architect overnight. An outbreak of illness could sweep through the cramped workers' quarters, decimating the core of skilled tradesmen. A war could conscript the strongest laborers, leaving only the very young and the very old to push the stones. The project didn't just need stone and timber, it needed continuity. It needed that master sculptor to teach his apprentice for 10 more years. It needed that team of haulers to return, season after season, remembering the precise rhythm needed to move a monolith up a ramp. When we see a beautiful, finished capital lying next to a rough, unadorned column base, we are seeing a snapshot of that ecosystem breaking down. The artistry was ready, but the basic structure was not. Or perhaps the structure was complete, but the artist never arrived to crown it. These are human stories of interruption, of promises between generations left unfulfilled. They remind us that the greatest vulnerability in any ancient megaproject was not the foundation of stone, but the foundation of shared knowledge and sustained purpose, a thread that, once broken, was often impossible to reweave. Even the most powerful civilization cannot command the rain. For all their ingenuity in moving stone and organizing labor, ancient builders worked within a system far larger than any empire, the local climate. Environmental pressures did not just influence construction, they could issue a final, non-negotiable veto. To reconstruct why a project halted, we must often look beyond ledgers and tool marks and into the very air and soil of the time. A prolonged drought, for instance, was a multi-pronged catastrophe. It evaporated the water needed to mix the vast quantities of mortar and plaster for a city's walls. It lowered river levels, stranding the heavy barges meant to transport stone. It withered the crops that fed the army of laborers, forcing them back to their own failing fields. Conversely, too much water could be just as devastating. At the great Mississippian city of Cahokia, near modern-day St. Louis, archaeologists have studied the layers of earth within its monumental mound. Their analysis reveals periods of intense, repeated flooding along the Mississippi River bottomlands. For a society that built its sacred calendar and civic life around solar alignments and seasonal ceremonies, such persistent inundation would have been more than a nuisance. It could have disrupted the very ritual timelines that govern the construction of new mounds, throwing the spiritual and social order into chaos. The environment left its signature in other ways, too. Scientists use a method called dendrochronology, the study of tree rings, to read the past like a book. When wooden tools, support beams, or even charcoal from a hearth are preserved at an unfinished site, each ring tells a story. A series of narrow, tight rings indicates years of poor growth, often due to drought or unseasonable cold. These were years of hardship, of scarce resources and hungry populations. If the tree was cut during such a period, it speaks volumes about the stress the society was under. It suggests that the energy required for monumental building may have been redirected toward sheer survival. Reconstructing these climatic conditions adds the final, crucial layer to our understanding. It shows that abandonment was rarely a simple choice between continuing or stopping. Often, it was the culmination of a slow, grinding pressure. A decade of diminishing harvests would strain the grain stores that fed workers. A generation of irregular floods would erode faith in the leaders who promised the gods favor. The project did not fail because the architects miscalculated the weight of a stone. It faltered because the entire supporting network, the agricultural and hydrological foundation of the society itself, began to shift. This reveals a profound truth about the ancient world. Their greatest constructions were not acts of domination over nature, but delicate and ongoing negotiations with it. They chose building sites based on water sources and solar paths. They timed their labor to the agricultural cycle. When that delicate balance was upset, even the most ambitious dream could be gently, inexorably reclaimed by the land. The unfinished site becomes a fossil of that broken negotiation, a place where human ambition finally met the quiet, immutable force of a changing world. A new ruler often sees his predecessor's unfinished dream as a political liability. In the Valley of the Kings, the silent corridors of abandoned tombs map a dynasty's shifting loyalties with stark clarity. A pharaoh would ascend the throne and immediately commission his own eternal house, diverting master architects, precious materials, and thousands of workers from the half-completed tomb of the king before him. That older project, once the center of a nation's focus, would be sealed and forgotten, its galleries left echoing with the ghosts of a discontinued ritual. This pattern reveals a hard truth. The most fragile phase of any ancient project was the transfer of power. A grand vision required a patron's unwavering will to sustain it across decades, and when that patron passed, his vision often passed with him. The stones themselves tell this story of succession, not through cracks or flaws, but through the sheer silence of work abruptly redirected. This phenomenon reaches far beyond the desert necropolises of Egypt. Across the breadth of the Roman Empire, a quieter but equally profound revolution left its mark on the landscape. As Christianity moved from persecuted sect to state religion over the 4th century, a wave of ideological change washed over the built environment. In city squares from Gaul to Syria, Ambitious new temples to Jupiter or Apollo were left half-raised, their grand colonnades only partly erected. The conversion was not merely spiritual, it was a massive reallocation of civic resources and identity. Imperial funding and official favor now flowed toward the construction of basilicas, not pagan shrines. The methods frozen in these sites are particularly telling. You might find a perfectly carved altar stone meant for animal sacrifice, left stacked in a mason's yard beside blocks already dressed with crosses. The construction process itself was caught in mid-transformation, a physical record of a society rewriting its core beliefs. Reconstructing the purpose of such a structure, then, becomes an act of historical triangulation. We must hold the architectural evidence in one hand and the political record in the other. An expansive foundation with a specific east-west orientation might clearly indicate a pagan temple layout. But without understanding the edicts of Emperor Theodosius, who formally prohibited pagan worship near the end of the 4th century, we cannot fully grasp why the walls never rose above their third course. The unfinished state is no longer just about labor or logistics. It is a direct reflection of a top-down command that rendered the building's very reason for being obsolete. The conversion created a paradox. The methods for building were still perfectly understood, but the will to apply them had vanished overnight. These sites of ideological abandonment challenge us to see history not as a smooth line, but as a series of sharp turns. A change in leadership or belief could act like a geological fault, severing the continuity of a project instantly and completely. The workers didn't slowly drift away, they were formally reassigned. The quarries didn't gradually halt, their output was redirected by imperial decree. This makes these unfinished places uniquely powerful time capsules. They preserve the moment before the old world was fully swept away, showing us the last breath of a soon-to-be-forgotten god, the final stroke of a chisel carving a now irrelevant symbol. In their frozen transition, we witness the immense power of an idea, not to build but to unbuild, leaving a skeleton of stone as a monument to a revolution in the human mind. Grand architecture was the ultimate economic indicator, a public display of wealth so immense it could be measured in stone. Behind every soaring column lay a mountain of coin, a river of grain, and a web of trade stretching to the horizon. To sustain such an endeavor required a constant, roaring fire of capital, fed by taxes, tribute, and commerce. When that fire began to sputter, the construction site was often the first place to grow cold, and its unfinished state becomes a ledger of fiscal strain written in material choices. We can read this ledger by noticing the subtle downgrades. A temple foundation might start with gleaming marble shipped from across the sea, a statement of power and connection. Then, in the upper courses, the stone changes. The marble gives way to a good but local limestone. This is not an aesthetic choice, it is a budgetary one. The long-distance trade route became too expensive, or the ships were commandeered for more urgent duties. The builders adapted, using what was at hand, silently signaling a contraction in the project's economic reach. Even more telling is the fate of the materials themselves. An unfinished site can become a quarry for the next generation's ambitions. In Rome, stones from abandoned imperial building projects were frequently carted away to construct churches or fortifications centuries later. In medieval Europe, the half-built nave of a cathedral might have its dressed stones carefully removed to reinforce a city wall against a new threat. This act of recycling is a powerful clue. It tells us that the original vision was not just paused, but officially terminated. The materials were no longer seen as part of a future masterpiece, but as an available resource to be liquidated, repurposed for a more immediate, often defensive, need. The economic value of the dream had been stripped down to the bare utility of its parts. To understand the why, we look beyond the site to the broader financial climate. Numismatics, the study of coinage, provides startling snapshots. The discovery of a large coin hoard buried near an unfinished palace, filled with currency from the very years construction halted, suggests a period of profound instability. People were hiding their wealth, fearing collapse or invasion. Trade records on clay tablets or papyri might show a steep decline in the shipments of cedar, copper, or tin right before a project stalls. These are the vital signs of an economy entering crisis, where long-term investment in prestige gives way to the urgent conservation of basic resources. A poignant example of this economic triage is found in the early Ming dynasty of China. The Hongwu emperor, founder of the dynasty, began planning a grand and fitting tomb complex. Work commenced, but the scale of the final structure is believed to be far more modest than initially conceived. Why? Because the empire's treasury and manpower were being funneled into a project of even greater perceived necessity: the reinforcement and expansion of the Great Wall. This was a stark calculation of priorities. The eternal resting place of an emperor, while important, could be scaled back. The immediate physical defense of the northern frontier from nomadic incursions could not. The unfinished state of the original tomb plan, inferred by archaeologists from its layout and scope, is a direct reflection of that national budget meeting a harsh reality. It marks the point where symbolic architecture yielded to strategic survival, where the money did not so much run out as it was forcibly redirected to meet a clearer and more present danger. This pattern repeats across history: the grand public bathhouse that never received its plumbing because a drought collapsed the agricultural tax base. The Victory Monument that stalled when the silver mines ran dry. These projects did not fail due to a lack of skill or will, but because the complex, invisible economy that breathed life into them simply exhaled its last breath. The stones were left waiting for a prosperity that never returned, making each unfinished wall a silent monument to the delicate, and often fragile, relationship between ambition and account books. The final step in our reconstruction is perhaps the most breathtaking: a bridge built from data into the realm of what might have been. This is theoretical reconstruction, where science meets informed imagination to complete the unfinished sentence. After gathering every scan, material analysis, and historical clue, we now feed it all into a digital crucible. The goal is to create a perfect digital twin of the project as it was intended, a ghost building rendered in pixels and light. This is where tools like Building Information Modeling, or BIM, become our time machine. Originally developed for modern architects, this software is now used by archaeologists to test hypotheses with a rigor that was once impossible. It allows us to move beyond sketches and into a dynamic, three-dimensional simulation where every stone has weight, every beam has stress, and every design choice has a consequence. We can ask the silent stones questions they could never answer on their own. For generations, scholars have debated the final form of the Pyramid of Menkora at Giza. Its lower courses were clad in costly red granite, but the upper portions are rough, unfinished limestone blocks. Was this always the plan, a two-tone design for symbolic reasons? Or was the pyramid left in a rushed, incomplete state, its smooth white Chura limestone casing never applied? Using BIM, researchers can create a model of the pyramid's core, then digitally apply that hypothetical limestone casing. They can calculate the precise volume of stone needed, map the quarry sources, and even simulate the construction ramps required to place those final stones. The model can test the structural implications of each scenario, revealing which completion method aligns with the builder's known techniques and the site's physical evidence. This turns a centuries-old debate into a series of solvable engineering problems. Another powerful example waits at the Temple of Artemis in Sardis, one of the largest classical temples ever conceived. Today, its footprint is a forest of a few standing columns and many fallen drums. Historical accounts and partial foundations suggest a grand design with a double colonnade, a wraparound hallway of columns. But was this plan fully realized before work halted? By scanning the entire site and every scattered fragment, researchers can digitally catalog each piece of stone, noting its dimensions and tool marks. The software can then attempt to fit these pieces together like the world's most monumental jigsaw puzzle within the known foundation. It can test if the number and style of completed column drums match the requirements for a single or a double row. The digital model becomes a proving ground, visualizing the most probable completed form based on the hard evidence of what was actually built, not just what was written. This process is the opposite of fantasy. It is a disciplined visualization bound by the rules of physics, material availability, and the cultural grammar of the period's architecture. It gives us something profound, a glimpse of the lost skyline of the ancient world. We can digitally walk through the nave of a cathedral that never was, or stand in the shaded courtyard of a palace that never housed a king. We see the play of light through non-existent windows at the equinox, understanding the sacred alignments the architects carefully planned. This final, theoretical stage completes the circle of our investigation. It takes the silent, static evidence and breathes dynamic life back into it, allowing us to witness the culmination of a dream that history interrupted. In doing so, it offers a poignant reminder that every finished monument we admire today was once just such a fragile vision, one decision, one shipment, or one season away from remaining forever as a ghost in the machine. A single clue is a whisper, but a chorus of disciplines can make the past speak. The true power of reconstruction lies not in any one field of study, but in the moment they converge, when the geologists' report and the historian's scroll begin to tell the same story. This is interdisciplinary synthesis, the final, essential method where we weave every separate strand of evidence into a single, stronger rope. No single expert holds the master key. The architect cannot explain a famine, and the climatologist cannot date a chisel mark. Only by forcing these languages to communicate do we hear the full, complex truth of why the tools were laid down. Consider the enigmatic Nurag towers of Sardinia, those ancient stone fortresses that dot the island's landscape. Many were completed, but others stand as skeletal rings, their central towers never raised. For a long time, their abandonment was a quiet mystery. The stones themselves offered no obvious flaw. The answer did not come from archaeology alone, but from a conversation between fields. Metallurgists analyzed bronze fragments from the sites, tracing the source of the tin and copper. Their data revealed a sudden and severe disruption in long-distance trade networks that supplied the alloy for tools. At the same moment, paleobotanists studying ancient pollen cores from nearby bogs detected a dramatic shift in the vegetation. The evidence showed a rapid transition to a drier, harsher climate. Meanwhile, settlement pattern studies indicated that smaller villages were being abandoned, with populations consolidating into fewer, larger centers. Individually, each finding was an interesting fact. Together, they formed an undeniable narrative. A climate shift stressed local agriculture, forcing social reorganization. This internal strain coincided with the collapse of the distant trade routes that provided the essential material for advanced tools. The society building the Nurag found itself squeezed from within and without. The ambitious, resource-intensive project of completing the central tower was no longer feasible. The stones were left in a ring, a monument to a world that had changed faster than their plans could adapt. This synthesis does more than solve a puzzle. It transforms how we see the past. It forces the ceramic specialist to talk to the geophysicist. The epigrapher deciphering temple accounts must listen to the osteologist studying the remains of the workers for signs of dietary stress. This collaboration shatters simplistic explanations. A project wasn't halted just by war, or just by drought, or just by a bad king. It was halted by a perfect storm of interconnected pressures, a cascade where a failed harvest in one region could break a supply chain in another, which could then stall a construction site a continent away. The story becomes richer, more human, and more resonant with our own understanding of how complex systems fail. In this light, a botanist's vial of ancient pollen is not just a record of plants. It is a report on the weather that delayed a quarrying season. An economist's analysis of coin hoards is a window into the anxiety that froze an imperial budget. The unfinished site becomes a unique crossroads, a place where every branch of human knowledge must meet to answer a single, profound question. This collaborative spirit is the ultimate lesson of the unfinished. It teaches us that the past is not a territory owned by one discipline, but a common ground we are all tasked to map together. By listening to every voice in the chorus, we finally hear the full melody of a lost ambition and understand the many quiet reasons it faded into silence. The digital ghost of a building is not a fact but an argument. When we use pixels to complete what time left undone, we are not merely restoring a structure, we are making a series of powerful interpretive choices. Each line drawn, each texture applied, and each shadow rendered is a statement about what we believe the past intended. This act of virtual completion carries a profound ethical weight, for the images we create can solidify into public memory, shaping how generations understand a culture's legacy. The responsibility, then, is not just to technical accuracy, but to intellectual honesty. Do we present a single, polished, definitive version of an ancient temple, a visual statement that suggests we know all the answers? Or do we embrace the uncertainty inherent in the evidence, creating multiple models that showcase competing possibilities, from a brightly painted facade to one left in plain stone? Presenting one definitive outcome risks closing the door on inquiry, turning a dynamic mystery into a static postcard. It can inadvertently impose modern aesthetic values, favoring clean lines and symmetrical perfection over the more experimental or culturally specific forms the builders may have envisioned. There is a delicate line between reconstruction and appropriation, between honoring a vision and overwriting it with our own cultural preferences. The ethical path requires transparency. It means labeling every digital recreation clearly as an interpretation, not a rediscovered truth. It involves annotating models with notes on where the evidence is strong and where educated guesses begin. This approach transforms the reconstruction from a spectacle of completion into an educational tool about the very process of history, about how we know what we think we know, and about the enduring presence of loss. This digital stewardship must also extend to the physical sites themselves. A breathtaking virtual tour of a completed tomb can inspire wonder, but if it is not framed carefully, it might also inspire reckless behavior. The ethical reconstruction must actively discourage damaging tourism or, in extreme cases, unauthorized attempts by enthusiasts to physically finish the work themselves. Our models should come with a digital covenant, an understanding that their purpose is to protect and explain the fragile original, not to replace it or provoke its harm. Ultimately, the most respectful reconstructions are often collaborative. Where possible, they involve dialogue with descendant communities, those who carry the cultural memory and spiritual connection to a place. Their insights can guide color choices, symbolic meanings, and spatial uses that no archaeological scan could ever detect. This collaboration ensures the reconstruction honors not just the stones, but the living spirit they were meant to house. In the end, the greatest value of rebuilding these unfinished dreams may lie not in the final image, but in the thoughtful conversation the process demands. It asks us to sit with the gaps in our knowledge, to respect the silence of the stones, and to remember that sometimes preserving the question is more important than insisting on an answer. These ancient pauses hold urgent lessons for our own age of ambition. The cracked obelisk and the silent quarry are not just historical footnotes, they are masterclasses in risk management written in stone. They reveal with brutal clarity the universal pressure points that can bring even the most confident project to its knees. A primary lesson is the peril of a brittle supply chain. The Roman temple that switched from imported marble to local limestone, or the Bronze Age palace that stalled when tin shipments ceased, teach us that reliance on a single, distant resource is a profound vulnerability. Modern engineering faces the same test, where a disruption in one global port or a shortage of a rare earth mineral can halt production lines for everything from microchips to electric vehicles. The ancient solution, visible in their adaptations, was redundancy and local sourcing where possible, a principle that resonates deeply in today's conversations about resilience and sustainability. Equally critical is the danger of over-centralization, whether in a single patron or a monolithic funding source. The city of Amarna, which lived and died by the pharaoh's command, is the ultimate cautionary tale. Its fate demonstrates that a project whose vision and resources flow from one person or one narrow interest possesses a terrifyingly short half-life. Modern megaprojects, from urban developments to space initiatives, learn from this by building broad-based coalitions, securing multi-stage funding, and designing for legacy beyond any single administration or CEO. It is about engineering not just the structure, but the social and political ecosystem that will sustain it across decades. This connects directly to the ancient mirror of our own systemic fragility. The collapse of the late Bronze Age around 1200 BCE did not happen with a single battle. It was a slow unraveling where interconnected systems, trade, agriculture, diplomacy failed in a cascade. Grand construction from Greece to Egypt halted not because builders forgot their craft, but because the complex web that supported them disintegrated. Today, we speak of global supply chains, climate stress, and financial interdependency with similar unease. Studying these ancient collapses reminds us that our systems, while more technologically advanced, are no less vulnerable to cascading failure. It argues for building slack into our systems, for designing projects that can adapt to shock, much like the builders at Stonehenge who shifted from distant Bluestones to local sarcens when their original plan became untenable. Ultimately, these unfinished sites teach a profound lesson about the social contract of ambition. A pyramid or a cathedral was not just an engineering challenge, it was a societal promise. It required the sustained consent of the people who provided the labor, the farmers who provided the food, and the artisans who provided the skill. When that contract broke through famine, unfair conscription, or a loss of faith in the vision, the project became impossible. Modern project management echoes this in its focus on stakeholder engagement, community benefit, and ethical labor practices. The most resilient design is one that is seen not as an imposition, but as a shared investment in a common future. By listening to these ancient silences, modern engineers and architects gain more than technical insights, they gain wisdom. They learn to plan for the second-order effects, to value adaptive capacity over rigid perfection, and to remember that the true foundation of any lasting achievement is not concrete but trust. The stones left behind ask us a simple, enduring question. Are we building only for our own moment, or for the countless unwritten days that will follow? An unfinished building is a question permanently etched into the landscape. It challenges the most comfortable story we tell about the past, the narrative of steady, linear progress from primitive to advanced, from plan to completion. History, as we often imagine it, is a book where every chapter leads neatly to the next. But these sites are pages torn out, their sentences trailing off into silence. They represent the path not taken, an entire alternate history frozen in stone. What if the great obelisk had been raised? What if the sacred city had been fully inhabited for centuries? The silent quarry holds not just a failed project, but a vanished future, a world that was meticulously prepared for but never arrived. This forces us to confront the profound contingency of history, the realization that the world we know was built not on inevitability, but on a fragile series of choices, accidents, and interruptions. The completed monuments we admire are just one possible outcome, while the unfinished ones show us the ghost of another possibility, lingering just beneath the surface of what did happen. These silent places are also deeply poignant reminders of the limits of raw ambition and the transience of earthly power. A pharaoh could command a mountain of stone, but he could not command the bedrock to be flawless. An emperor could mobilize legions, but he could not stop a changing climate from swallowing his supply routes. The unfinished project is the moment where absolute will meets an immovable constraint, whether physical, economic, or temporal. It is a humbling equalizer. In their incomplete state, the grand designs of kings and priests become strangely democratic. They speak a universal language of aspiration meeting limitation, a story every human understands from their own smaller endeavors. The cracked stone at Aswan does not just record a technical failure, it records the moment a god-king's decree was overruled by a deeper, older law of geology. This perspective invites a subtle but powerful shift in how we assign value. We live in a culture obsessed with the product, the finished artifact, the checked box. Ancient societies were certainly driven by completion, but their unfinished works ask us to reconsider. They ask us to value the process over the product. There is immense meaning in the endeavor itself, in the collective skill, coordination, and vision that went into the attempt. The carefully dug foundation trench, even if no wall ever rose from it, is a testament to human intention and labor. The stockpile of perfectly dressed stones, waiting for a wall that was never built, still represents hundreds of hours of mastered craft. When we focus solely on the end result, we miss the story of the society in motion, the problem solving, the logistics, the everyday lives of the people who showed up to work. An unfinished site preserves that motion like an insect in amber, allowing us to appreciate the magnitude of the effort, irrespective of its final success or failure. In doing so, these places teach us to find a certain beauty in the fragment and a profound narrative in absence. A completed Roman temple is a closed statement. A half-built one is an open question. Its missing roof lets in the sky. Its absent walls frame the landscape it was meant to dominate. This incompletion creates a space for our imagination to enter, to collaborate with the past in a way a perfect, restored monument never could. We are forced to become active participants in the story, using the clues left behind to mentally complete the picture. The absence becomes as eloquent as any presence, telling us what was missing, what was needed, what was dreamed of but never attained. It speaks of resources that vanished, of priorities that shifted, of a vision that outran its time. Ultimately, this demands a specific kind of humility from us as interpreters of the past. We must resist the temptation to see these projects solely as failures, as symbols of decline or incompetence. That is a modern judgment projected backwards. Instead, we must approach them with empathy for the scale of the ambition and respect for the very real obstacles that arose. Our task is not to pity the unfinished, but to listen to what its silence is telling us about the realities of the ancient world, its pressures, its calculations, its sudden changes of fortune. These sites are not evidence of a lack of capability, but often evidence of a clear-eyed decision to stop, to redirect energy, to adapt. They show us ancient people not as mystical superbuilders, but as pragmatic managers confronting complex, real-world problems. In a world that often shouts about its triumphs, these quiet, interrupted places have a different, more contemplative wisdom to share. They remind us that history is not just a parade of finished things, but a rich tapestry woven from both achievement and aspiration, from the stories told in full and the stories that remain forever beautifully incomplete. The frontier of reconstruction is no longer just a quiet dig site. It is a humming laboratory of the impossible. We are entering an era where our tools are beginning to perceive the past in ways that would seem like pure magic to the archaeologists of just a generation ago. This new wave of technology does not replace careful excavation. It supercharges it, allowing us to see through stone, decode invisible patterns, and ultimately step inside the building process itself. The first breakthrough comes from a surprising collaborator, artificial intelligence. For decades, a researcher might spend a career studying tool marks, slowly building an intuitive sense for the style of a particular culture or period. Now we can feed an AI system thousands of high-resolution images of these marks from sites across the Mediterranean. The algorithm does not get tired. It scans every microscopic striation, every angle of impact, and begins to identify patterns of force and technique that are simply too subtle for the human eye to consistently recognize. It can compare a chisel stroke from an unfinished temple in Greece to one from a completed tomb in Turkey, and with startling accuracy, suggest not just a similar tool, but potentially the same school of craftsmanship, tracing the invisible migration of skilled artisans across the ancient world. This moves us from guessing about methods to statistically modeling them, creating a probable sequence of construction with a confidence we have never had before. Beyond the surface, we have technologies that grant us a kind of vision. Think of a stone block from a Roman arch, seemingly solid and silent. Using a technique called neutron imaging, we can now peer inside it without causing the slightest damage. Neutrons pass through dense materials like stone far more easily than X-rays, but they interact strongly with light elements like hydrogen. This means we can detect the faintest traces of organic material long since vanished, the ghost of a wooden lever left inside a lifting hole, or the residual outline of a metal clamp that once held two blocks together. It reveals the hidden engineering, the internal skeleton of the builder's technique, showing us solutions to problems we did not even know they had solved. And looking ahead, the horizon holds even more promise. Researchers are experimenting with quantum sensors, devices so sensitive they can detect minute changes in gravity. The idea is to one day map entire underground complexes, the foundations, water channels, and storage rooms of a city, from the surface without a single shovel breaking ground. It would be like having a detailed architectural plan of a buried metropolis, revealing the full intended scope of a project before we ever touch it. As these tools mature, they converge into a single, transformative experience, virtual reality. This is where reconstruction moves from the page and the screen into a space you can inhabit. We are not just talking about a static model of a finished temple. We are talking about a dynamic simulation of its creation. Imagine a digital environment where you stand in the dusty footprint of a half-built pyramid. You hear the distant sounds of a quarry. You look up and see, materializing in real time, the next course of stones being maneuvered into place on enormous earthen ramps by teams of digital workers. You can walk around the active construction site, watching the logistics unfold, seeing how the temporary supports for an arch are positioned before the keystone is set. You become a virtual ancient apprentice, learning the rhythm and the risk of the method from the inside. This is more than a spectacle, it is a profound research tool. An architect can test a theory about a lifting technique by literally trying it in the simulation, experiencing the sightlines and physical challenges of the workers. A historian can assess whether a proposed construction timeline feels plausible when witnessed at human scale and speed. It turns abstract data into embodied understanding. This technological leap does something essential. It restores narrative to the silent stones. A static ruin speaks of an end. A dynamic simulation speaks of a middle, of a process teeming with life, decision, and effort. It allows us to experience the ambition not as a frozen fact, but as a living endeavor complete with its noise, its chaos, and its staggering coordination. We shift from analyzing a corpse to shadowing a living body at work. The ultimate goal of this digital frontier is not to claim we have the final answer, but to open up deeper, more nuanced questions. By giving us the tools to see more and imagine more accurately, we become better listeners to the past. We can ask the stones more sophisticated questions and, in their silent language of form and fracture, hear more complex and human replies. The unfinished project, once a puzzle of absence, becomes a portal. The principles that halted a pyramid are quietly at work in a half-built skyscraper on your city's skyline. Our modern world is not immune to the ancient script of interruption. The skeletal frames of stalled condominium towers, the concrete stubs of abandoned highway extensions, and the vast, empty grids of planned cities waiting for residents that never came. These are the future archaeological sites of our own civilization. By applying the very same forensic mindset we use on ancient quarries, we can begin to read these contemporary ruins. We can analyze the funding cycles that ran dry, trace the political mandates that shifted with an election, and examine the material choices that signaled a budget crunch, seeing our own era's soaring ambitions and sobering failures in a startling new light. This connection transforms dusty history into an urgent mirror. The challenges of scale, logistics, and sustained collective will are not relics of a bygone age. They are timeless human conditions. Consider a modern ghost city, its empty boulevards lined with streetlights that have never been switched on. The forensic clues are already there. You can see the phased construction, where the first district was completed with high-quality finishes to attract investors, while later phases show a shift to cheaper materials as capital grew tight. The architectural plans, likely stored in digital servers that may one themselves become unreadable, tell a story of grand vision. But the on-site evidence, the unused bags of cement hardened into stone, the construction cranes left to rust in place, tells the story of a broken promise. This is no different from the stockpiled gypsum plaster at Amarna, waiting for a decorative program that political change rendered irrelevant. The pressures are eerily familiar. A massive infrastructure project like a high-speed rail line meant to connect regions can be halted not by a flaw in engineering, but by a shift in public sentiment, a legal challenge over land, or a recession that redirects government funds to more immediate social needs. This is the modern equivalent of a pharaoh's successor redirecting labor and stone to his own tomb, a reallocation of resources based on a new set of priorities. The concrete pillars that rise from a field and then abruptly stop are our civilization's version of the abandoned obelisk, a monument to a calculation where the projected cost finally outweighed the perceived benefit. Seeing our world through this archaeological lens fosters a profound humility. It reminds us that our glass and steel towers, for all their technological sophistication, are just as vulnerable to the fragile networks of capital, politics, and social consensus as any stone temple. A trade war can embargo a critical component as effectively as a Bronze Age shipwreck. A climate event can flood a critical transport hub just as an ancient drought stranded stone barges. The breaking point may be digital, a corrupted financial model, a cyber attack on a construction firm, but the outcome is the same, a frozen site where the human energy has dissipated. This perspective makes the study of ancient unfinished projects not a niche historical pursuit, but a vital study in human endeavor. It gives us a longer timeline against which to measure our own struggles, showing that the tension between dream and reality is a constant. By understanding how past civilizations navigated or failed to navigate that tension, we gain not predictions but wisdom. We learn to look at our own ambitious blueprints and ask the older, deeper questions about the resilience of their supply chains, the breadth of their support, and the legacy they intend to leave if, for any reason, the work must pause tomorrow. The silent stones of the past are no longer just artifacts. They are consultants, whispering lessons across the centuries to anyone willing to listen. These silent scaffolds are not tombstones for ambition, but classrooms built of stone. Our journey reveals that every unfinished ancient project is an open book, its pages left unturned for centuries, waiting for us to learn its language. A cracked obelisk is not a failure. It is a dialogue with the past, a raw and unfiltered conversation about the very nature of human endeavor. It speaks of ingenuity meeting an immovable flaw, of supply chains stretching across continents until they snap, of a king's command silenced by the quiet turning of a season. By reconstructing their methods, we do far more than solve technical puzzles. We recover lost human stories. We hear the echo of the foreman's last order, see the mason's hesitant chisel stroke, and feel the collective sigh of a community redirecting its energy toward survival. This process connects us to a universal struggle, the profound and timeless effort to build something that outlasts our own brief moment, to etch a meaning onto the landscape. These sites teach a quiet humility before the vastness of time. They demand respect for the sheer volume of effort, coordination, and hope embedded in every stone, whether it ever found its place in a wall or not. They remind us that our shared human heritage is not just a gallery of finished masterpieces, but a workshop full of half-formed ideas, brilliant adaptations, and sober recalculations. If this exploration has reshaped how you see the ruins of the world, if you now look at a scattered foundation and see a story instead of a stump, share your thoughts in the comments below. Your perspective adds another layer to this ongoing reconstruction, and subscribe to join us as we continue to piece together the grand, unfinished symphony of human history, one silent stone